Hey, this is Don from Palo Alto Technologies again, back with another video. I know it's been a while, but if you've been looking at my socials and seeing the stuff I was posting, I was busy learning a new technology, so to speak, or refreshing my knowledge on a new technology. I'll be doing a video on that. Won't if you watch the post, you know that technology, what it is. If you don't, it's Cisco Secure Workloads. Haven't touched it since it was like Tetration. So I'll be messing around with that and, looking at how that fits in the whole microsegmentation conversation. But this video is not about that. This video is about a previous post that I put about active on Palo Alto firewalls. Now, I've done plenty of videos on your typical active standby setup. I did it on the secure firewall. I've done it on Fortinet, and I've done it on Palo. I've also done a active on the ASA with multi-context mode. This one is going to be, I think I did one on Fortinet as well. And now I'm going to do it on the Palo Alto firewall. Now, active on secure firewall is a little bit different because there's no such thing as multi-context. It's multi-instance. So if you're going to do active, you would technically be logically creating separate firewalls and then actively sending the traffic. With the Palo Alto, we're going to use active, and we're going to talk about floating IPs, not ARP sharing this time. Now, before we get into that, I'm going to show you the whiteboard that I created the original post off, and then we're going to talk about that, and then I'll show you what it looks like in the lab. Before we get into that, if you haven't already, and you like stuff like this, please don't forget to share, comment, like, and subscribe to the channel. Views is going up, subscribers going up, so I really appreciate that. And if you want to take it to the next level and you want to become a supporter of the channel, I have a membership as well. Link's going to be in the description. Don't forget to hit that if you really want to support the channel. That helps me get more gear so I can do more lab stuff, and you will get access to videos early. I have 3 guides that's coming out for anybody that's trying to get their CCNP. You'll have access to that. Any guide I put out after that, free of charge, will be given to my members. Now, you'll also be able to buy them if you don't want to become a member. That's fine. But if you would like to just support the channel and get any guides I put out early, hey, videos early, become a member. With that being said, let's get into the whiteboard. So here's the whiteboard that I created before about active on Palos. So let's explain this a little bit. Now, you have your internet up here at the top. Let me get over to the board because it does this. So you have the internet over here to the top. I just put them in green so you know there were 2 different internets. And then you have your Palos here at the bottom. You have your HA link. Now, those are 2 links if you don't want to include the management link, but you can also have this Q3, I believe it's, don't quote me on it, but it's a third or HA3 interface that does synchronization and session data and stuff like that, or synchronization. It's high-speed link. So from a PA perspective, what happens is from a floating IP, each firewall has its own respective IP address. Now, this is the most confusing part of configuring this because technically, in the other versions, you wouldn't do active the way they're doing it, basically. So what happens is firewall 1 owns, let's say, it owns firewall 1 on the right-hand side is active secondary, active primaries on the left-hand side. So for the floating IP in white, this 192.168.26.253 is owned by firewall 1. This floating IP 200.110.100 is owned by firewall 1. Now, if you look at the active secondary, the floating IP of 192.168.27.23 is owned by firewall 2. And then the floating IP 200.110.101 is owned by firewall 2. Now, if you look underneath that, you'll see some individual IP addresses. So if we look at the WAN side, we have 10.110.1 is owned by firewall 1, 200.110.2 firewall 2, and then 192.168.26.1 is owned by firewall 1, and then .2 is owned by firewall 2. Same about 27.2 is firewall 2, 27.1 is firewall 1. Now, from a floating IP perspective, the downstream devices will be talking to the floating IPs. So that's the basic setup. Now, what happens in a failover event? That's currently over here on the side here. If, let's say, Alice is in the, .27 network, right? She's technically talking to 192.168.27.253 will be her default gateway. And that's answered by firewall 2. But if firewall 2 went down for some reason, and technically she would be going out from a NAT perspective, she's going to go out as 200.110.101. But if firewall 2 went down, both of those floating IPs move over to the primary, or in this case, the secondary for the floating IP. And what ends up happening is now router one, or not router one, firewall one actually owns all the floating IPs. So it owns the 26.26, it owns 10.100, it owns 10.101, and it owns 27.253. So it owns all the floating IPs. So it's going to answer for Bob and Alice going to firewall one. Now, obviously, when that comes back, floating IP moves back based on configurations, but it's the same and vice versa, right? So if firewall one went down and two was up, well, the floating IPs that were originally owned by firewall one would move over to firewall two. Transparent to the user. Now, there is another setup here where you can do active-active with virtual wire. Now, that can get kind of hairy if you do something like, and I've seen this setup before, you have a firewall, like a secure firewall at the top, and then you're doing a active-active setup with virtual wire underneath it. You can run into some iffy problems if you do that. Case in point, like a failover doesn't fail over completely until you take one of the nodes out of the HA paired and it starts to work. I've seen that happen a couple times. So just be careful about design, right? Remember, like I said, design is more important than the actual config, because if you design it wrong, it's just going to be wrong from the start. So from when you originally set this up, you will set up the HA on both sides, but some of the things carry over. Case in point, you do anything from a virtual routing standpoint on the primary, goes over to the secondary. But what doesn't come over is you have to set each individual interface up on its own. All right, so you can't do it on the primary and it moves over to the secondary like you would do in the active standby setup. So with that being said, let's go in the lab. I'll show you the same setup as always, same firewall setup, but I'm gonna show you exactly what firewalls we're doing it on. So here we are at the lab here, and this is one of the firewalls, but I'm gonna show you it's the same firewall lab. I do all of this stuff in this firewall lab here. And I do have Cisco Score workloads on a lot of these agents here. We're going to talk about that on another video, but let's stick to this. Now it says active passive now. Before anybody tells me about why it says active passive, it's because I locked myself out in terms of Eve. So I locked the lab and I forgot what the password was. So I'm stuck with whatever it is. Now there is a way to do it, but I just don't feel like going and unlocking it from the CLI. So technically, these firewalls here are going to be active, right? So let's look at the configs. So we go in here from a device perspective, and I've done it on both sides. If we go to high availability, you will see that we are in active mode right here. So this is active, and this is device 1 compared to this device. It should be device 0. Yeah, so this is device 0, okay? Technically, when we do our configurations, you're going to see that I can assign certain things to certain devices. So now we have this in play from a HA communication standpoint. I have my HA links. Now I don't have 3 on here, or well, technically this is this HA3 interface. I don't have that here, so you don't see anything set up. But most of the time, even in active or active standby, people use this link if they want to. It's like a high speed session kind of thing, session syncing. So same thing on this side from an HA communication standpoint, same setup. Just show y'all that everything is technically the same. least from the HA setup. Then we have 80, and then what we have for a priority here. So this is the primary because the priority is lower. So now let's look at the active configuration. All right, actually, before we get into that, let's go in the network so you guys can see the difference. So the zones and all that stuff is the same from a zoning standpoint. We go to zones here, see our way in the land zone, pretty much the same. But if you look at the IP address, remember .2 like you saw in the picture, and then you have .2 here. You go over on this side, this should be .1, right? So .1, .1. So as you can see, unlike um, active standby, where everything just syncs over, you actually have to go in here and configure this, right, from an interface standpoint. Now, this is going to be completely different from the picture you saw because I didn't feel like going through and creating multiple floating IPs. I just want to demonstrate the floating IP concept. So the zones are the same. The virtual routers are the same. Pretty much this syncs over when you do it on the primary. This syncs over with the secondary, the active secondary. So this is, I only have static routes in here. So I have a static route to the internet and static route downstream. Now, the most important piece, now that you have this basic piece set up, is the floating IP setup. So if we go to our devices here, and then we go to active configuration, I don't know why that zoomed up, but you know what? I'm not going to complain. So you go to active configuration here. Let me see if I can go to active, and then you have this box here where you can configure your floating IPs. You can also configure ARP sharing, which is basically two devices sharing the same IP address. Now, I normally would do that on the inside just so everybody can send it, but I would use that in a certain scenario. We're just going to talk about floating IPs because this is probably the most confusing one out of all of them since I've learned this way back when. So what we're going to do on the inside interface, which is ETH5, we basically said we're going to put two IP addresses on here. All right. So I have two IPs. One's going to be .53 or 253. The other one's going to be .52. Now, I did this for a specific reason. I wanted to show you from a routing perspective. If I kind of finagled the lab where I have a static route with a tracking object that goes to .253, and if for some odd reason that object went down, it would switch to 252. In the real world, you probably never do this. It's probably one IP address for the most part. So what the configuration said, this is a floating IP. I'm not binding it to the active primary. I'm going to say, hey, the device 0 owns the IP because it's a 0 because lower priority wins. And then device 2 owns it if it goes bad, right? If something happens to the other firewall. And in reverse, I have floating IP is owned by device 1, and then device 0 is technically the standby. And then same thing on the other side. So 100 is owned by device 0, and then device 1 is a standby, and then 101 is owned by device 1, and then device 0 is the standby. This is why this is very important, right? So this is device 0. So anything that has device 0 in it, and it has that lower priority, owns those IPs. And anything that's device 1, that was device 1, will own their IPs that are given the priority for device 1. So from a downstream perspective, I'm not pointing it to the individual IP addresses that you saw in the network. I'm not pointing it to .2, I'm pointing it to the floating IP. So what's one thing that can trip you up with active on layer 3 floating IP stuff? Which it's really the NAT rule. I would say that was probably the most confusing piece was the NAT rule. So the NAT rule, you have the ability to have two separate NAT rules that NAT to two different addresses and bind them to the device itself. So device 1 or device 0. And what that looks like, let me make sure I get to the actives just so you can see it. So we're going to policy. It's going to sync regardless, but let's go to policy. And if we go to our NAT policy, well, I know why I did that in the lab because I wanted to show you like there's no active hits right now. And what we're going to do is when I go in the lab, I'm going to shut down OSPF, go in the secure firewall, and then I'm going to do a ping to go out of the PAs. Oh, actually, there are some hits here. So that means I must already did this already. So right here, this is a normal pat roll. Basically what this says is LAN, WAN is the zones. We got going out of, the destination interface, any interface. Really, from a source interface standpoint, we're just going to say, I made an object for our LAN. And then I'm going to say, hey, we're going to use a pat for this NAT. And you're going to pat it to the .100 that's owned by, and this is the most important piece, active HA binding. I'm binding this to device 0. So whatever's device 0 that owns this IP address, that's the NAT that's going to work, right? Now, if for some reason, and I manipulated it downstream, but let's say someone was going to the other gateway and they were going out of the other active firewall with this .101 address, well, then you would see, hey, this is bound to device 0. So you're going to go out of that 0 and you need that NAT rule to be bound to device 0 so that it would go out, right? Because technically device 2 or active secondary doesn't own the IP address 10.100. So this top rule would not work, right? It owns this right here, which is 101. So since we're active and both firewalls can forward, I needed to make another rule and kind of bind it to this. I don't know why this keeps doing what it's doing, but whatever. So I had to bind it to the device number 1. And as you can see, I do have some hit counts going on both. So now what we're going to do, we're going to go in here. You know what? I might have, yeah, I think I have this upstairs. So I'm going to have to close this real quick or log out and log in as HTML. I believe I have this running upstairs as well. What we're going to do, so we got ICE running here, so we can't. We log in here, security 101. So if I do show run section IP route, so I don't have that on here. So this is probably saying that we are okay. So we're going out to secure firewall because that is a N1, right? So that's the default originate in a not so stubby area for my people that's going for your Cisco stuff or just in general routing stuff. That's an N1, which is not the default. It's usually an N2. And remember OSPF path selection, intra or inter, intra, 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 enter E1, E2, N1, N2. I don't know why I got tongue tied on that. All right, so here's what we're going to do. We're going to point this. Let me see if that track object is still running. Now, since this is E, this has been running weird on me a little bit. So what we're going to do, sometimes I have to shut down VLAN 25 because it gets stuck. So first thing we're going to do, to get stuck from a routing perspective, is we're going to point this to 20, 26.23. 23, run a track. I believe it's 1. And then we're going to do the same thing with 27, 3, but we're going to do administrative distance. Now, if I know better, because I've seen this happen already, yeah, you see how the N1 is still stuck there? Even when I clear out the route, it still shows in there. So last time I had to do this for some reason, shut that. Now let's see the route. So that's going to 27 right now until that tracking object comes up. So I should be able to hopefully ping if that was the address that I was supposed to be going to. Make sure that was the, I could have been. Actually, it's supposed to be dot two. So that's again, it was 26 dot. There we go. So let's change something up real quick. Can't copy and paste it. Completely. See, I was looking at the diagram when I just did that, and that was completely wrong. Now it should be 26.2. I'm going to give you a no out. Now look at the route. That should be 252. There we go. So remember that was going to 252, and 252 is owned by 0. So that would be this device here, because we got the, no, that's 1. So sorry. That actually means the device that I'm actually on. So yeah, device 0 I own. Nope, it's device 1. Sorry. So device 1 actually owns it, and I can tell by the right here where it says device. Let's go back here. So this 252, like I said before, priority 10 means device 0 doesn't own it, and priority 0 means device 1 owns it. So now, if I were to go over here and look at the NAT policy, wait for the count to come up. So that says 374. So if we go up, the tracking object went up, so now it's not going to be there anymore. So we ping again. That should be going now to device 0, and we should technically see the count go up. So you see, yeah, so here we go. So as you can see, I didn't refresh that yet, but this was the original count before the tracking object went up. All right, and now this is technically the real count, right? Because I didn't refresh. So as you can see, I switched over from one virtual IP to the other virtual IP, and I had to rig it like this to show you, like, hey, what happens when the virtual IP goes down? You know, what would swing over? Now, technically, they're both in 26, the dot 26 network, because I did not make the downstream links any trunk links. So I'm kind of finagling or faking it as, hey, technically this is in the same routing domain. So I really wouldn't need to have a secondary IP address like a .252 in the same IP range. But I wanted to show you guys, like, hey, here's two IP addresses that are configured on here. One's owned by the other, but one's owned by its respective firewall. What happens if one of them goes down? And as you can see, it flipped out. Well, from the tracking object, it changed the routing and went to the other IP address. Now, in the real world situation, the .253 would have just moved over to the other firewall, and I would just keep going to 253. But I just decided to make it a little bit difficult and add a tracking object and all this other nonsense to it just to demonstrate an idea. Now we refresh this. And that makes it take some time to actually refresh to the actual count. But right now, see what we got here. Yeah, I don't think I have any more traffic going through this. Yep. Let's see. Yeah, so now this number is incrementing because I'm going to 253. So because I'm doing the 253, I shouldn't see any more increment values going up on 252 or going out of 101 because nothing's going to 252, which would technically get added to this 101 address. Technically, what device is this? Now, if you want to see a little bit more of, like, from a CLI perspective, 101, like I said, and this is the confusing part about active on Palo. Trust me, it takes you a couple times to actually like get it. At least configure it a couple times for you to get it. But as you can see, the values keep going up. For this one, this is not going to be so much because technically the primary, I don't believe this. I believe this is, but this gets a little weird from a logging perspective. This is why this is a corner cut case, because trying to manage this and like what IPs are owned by who can get a little stupid. All right. So most people will do active standby and not active. Right. And again, operational commands is just you can remove it, but most people don't do that. And if we go to our dashboard here, you would see that, my peer, which is the other side, is the active secondary and I'm the active primary. Meaning I'm active, but I'm primary basically from a sync communication standpoint or sync configuration standpoint for the things that do sync, like security policies, NATs, stuff like that. I'm not primary for interface configuration because obviously they have to be different. So let's jump back out of this and let's talk about what you just saw, and then we'll just close it out here. All right. So that was active or a brief demonstration of active on a Palo Alto firewall. Key concepts here that you got to remember is when you're doing the floating IPs, the floating IPs aren't technically, think of it like HSRP or first hop redundancy protocol. One device is going to answer or owns the floating IP until it goes bad, and then it sends the other device owns the IP at that point. All right. In this situation, I did a little finagling to try to simulate the move over. So what I did was I had a tracking object, and I said, okay, you're going to go to .253 when the tracking object is up, and if the tracking object isn't up, then you're going to have a route to go to 252. Now, 252 is technically owned by the secondary firewall, and 253 was technically owned by the primary firewall. So I was going to the secondary firewall for a little bit, and then when the tracking object came back up, I went to the primary firewall, even though I was in the same subnet, right? I just wanted to demonstrate like switching between firewalls for traffic. Now, in a real world situation, you would have one floating IP that's owned by one firewall, and then if that goes down, it would switch over to the other firewall. But at that point, you kind of like the only real benefit you get is the active forwarding. But if that's not really important to you, you're better off just going with the active standby. That is like 90% to 95% of the deployments you're going to see when it comes to HA. Right, that other 5% use cases where people use the active on any of the firewall platforms you see out there. So this is Don from Palo Alto Technologies again. Hope you liked the video. If you didn't get it the first time, rewatch the video and then learn the concepts. If you saw any of my posts, get the screenshot that I made or the diagram that I made, because that's going to help you with a little bit of theories. Read some of the documentation, but the best way you're going to learn it is you got to lab it up and see for yourself, and then break it. If it doesn't work for you, try to figure out why it's not working. That's the best way you're going to learn it, right? Labbing, getting your hands dirty in configurations is the best way you're going to learn new technology. So again, I hope you like this video. Be on the lookout for the next video that's going to be a little micro segmentation with secure firewalls. Be on the lookout for that. If you haven't done it already, please don't forget to share, comment, like, and subscribe. And again, if you really want to support this channel, consider becoming a member. You're going to get early access to videos and any kind of guides. I have 3 coming out pretty soon. Any guides I put out, will be yours free as long as you're a member. Again, you can also buy them as well when they come out. Time for Palo Alto Technologies again. Thank you. Have a nice day.